All right. Final time, I promise. Put our hands together for Andy Beach.
Hey folks, thanks so much. For those who haven't met me before, Andy Beach, I'm a former Microsoft employee, but I'm also a former Elemental employee. And if you want to go way back, Inlet Technologies, for those who remember. So an encoder from way back. I left Microsoft about a year ago. When I was there, unlike Amazon, they would never let me do first-party media products. And so a lot of my job as CTO was matchmaker. I love to find companies and go, I wish you two would put a thing together and you could make a thing, and then we could put some Azure in it, and then you could sell it, and that would make money. And so when I left Microsoft, I kind of kept doing a lot of that. And this is one of the things that I started with, which was marrying a SMPTE 2110 workflow with a company called Switch.io that I know very well, with a vNova codec called VC6 that's a hierarchical codec that has a lot of interesting, I think of it as a very AI-friendly codec as I dug into it and did research. So the challenge that we started with, the problem that we were talking about, is that AI has become ever present in everything we get to talk about, but it is something that we legitimately want to use in live media workflows where possible, where it makes sense. Traditional media pipelines are really built around human observation and presentation. So much of the video that we're working with now, however, really needs to be there needs to be machine perception built into what you're doing. So the more knowledge that we can hand over to the model in a low, small package, the better we can do. The problem that we have is all of those human cycles that we've built around tend to add more latency and more redundant infrastructure into what you're doing. Whether you're doing multiple proxies or other elements as what you're doing, you could get into a scenario where each channel that you want to feed into separate models might require a different form of a proxy or a different cut or some other piece of it. So it's not practical, it's not tenable. What we started looking at was using this VC6 codec that's a SMPTE standard. I'll get into that in a little bit, as a mezzanine codec on par with JPEG 2K, JPEG XS, ProRes, etc. The difference being that it doesn't require a full frame decode and doesn't necessarily require you to actually even decode the entire frame. So VC6 is, as I mentioned, it's a SMPTE standard. It's ST217-1. It's got a couple of things built into it that are interesting. It's got a scalable video ladder like SVC does on the MPEG side. And it also has something that's called a region of interest, the ability to define a set of pixels that you want to encode or decode or make changes to in the file versus decoding the entire frame. And by the way, I'm just reusing a SMPTE talk that I gave at MTS last year, so I'm probably going to burn through the slides so that you guys can feel free to ask questions. We then married this with Switch.io. Switch.io is a company that does multicast network overlays in all of the clouds. They started on Azure, which is how I became aware of them, but they're actually working in AWS, OCI, Google, a variety of places. They also work in private clouds, and they have two different products, a ground switch for routing traffic in local on-prem networks, and then Cloud Switch that's effectively the same software deployment running in the cloud for managing there. So with this hierarchical codec and VC6, we were able to set up a scenario where we're taking that 2110 feed into their ground switch. They can flip it into a VC6 mezzanine, send that single stream into public cloud. For this test, for the SMPTE work, we were running in Azure, but we've actually been doing all of our tests this year in OCI. But then we were using their fan-out capabilities on the multicast side to multicast different parts of the resolution, different size resolutions in different parts of the frame to a bunch of different models simultaneously. I don't think I have to go into a lot of detail to describe a hierarchical or a scalable video coding ladder here, so I'm going to quickly go through these. But in a nutshell, if you've got a 4K frame, you're probably at around maybe a 2 megabit per second on a given frame. At the top level, what they would call LOQ0. If you do one step down, or sorry, 2 steps down, you'd be at approximately 75% of the same bandwidth at about 500K and about a 540p image or frame. Likewise, you could step down to LOQ3 and be 90% of the bandwidth of that original frame that's going out at 270p. Or, as I mentioned, there's this notion of regions of interest. I don't have to send an entire frame of media. I can define a set of pixels that I want to send, and that can be dynamic. With this scenario, we were sending full frame to the model until it identified a player. We said we want to follow that player, and then it would just continually send us back the coordinates of wherever they were with a bounding box. And then we were able to just decode that frame, or that part of the frame. So we were effectively only sending about 1% of a 4K frame at any time to the model. In practice, this is what it looks like in software when it's running. This is the Switch console. They have already built in some agents that allow you to dynamically set up. So instead of actually having to go set up a bunch of different feeds, you can actually just use a chat interface and do a conversational, I want to set up X amount of feeds, I want to do facial recognition, I want to go find players, I want to find fouls, etc. It'll define the models that it needs to do the work, and then it'll ask you for endpoints and begin setting up the feed. And then what you see is the source feed coming in, and then a live feed on the other side where we've identified a bunch of different elements based on the workflow that we had defined on the program output side. So I think VC6 is the first of many different kinds of codecs that we're going to see at a mezzanine layer. I think in an era where we are wanting to put more and more AI into it, I think we are going to see mezzanine be a bottleneck in decode or latency for sending it out to multiple models. So I think we're going to look for smarter versions of codecs that allow us to either tear off low resolutions without having to reprocess the content and create a proxy, or send just a specific region of it. There's things inside of 265 that also allow you to do region of interest similarly, or different slices of the video. So I think there's other pieces that'll come along out there that are part of it. But I think it ultimately is valuable for the more work that we want to do inside of these AI models for a different part of a workflow. This is sort of what the overall topology looked like. We were starting, as I said, with 2110. We were actually also using HoloScan from NVIDIA as part of the setup because it's very 2110 friendly. That was going into the ground switch, and then we were doing just a single feed into Azure, and then sending that out to the multiple models from there, which were a mix of NVIDIA models and Microsoft models, and I think we had 111 Labs voice model that was also basically just creating a new narrative or a new announcer feed in real time for us. I've got a bunch of, because this was a part of a SMPTE presentation that we did, there's a ton of information. And if you hit that QR code, it goes to a blog post that Vnova did with NVIDIA, talking about the performance capabilities that they had around the codec. They've got CPU, GPU support today. They're in the midst of doing ARM support and I think Qualcomm support as well for other chipsets. So they're moving it into a variety of places for the ability to do encode and decode. I don't think we need to get into those. So I think what it came down to for me is I think it lights up improved operational efficiencies when you're deploying your initial live topology, so that you're not having to create a bunch of additional proxy pieces that may slow down the live feeds if you want to inject models into the workflow. I think it can also make for faster response times with the models because you're not sending it necessarily as large of a frame. The reality is, for a lot of the work we were doing with the models, the lowest resolution was all we needed unless we were doing facial identification. If we just wanted to find someone on a field or some other element, the 270 feed was actually perfectly fine, and much more lightweight and easier to get in and out of the model to get the data results versus the 4K, which just takes time for decode. So it allows you to scale up on AI capabilities, and at the same time, you're still ultimately keeping your GPU and your CPU workloads down because you're not spending as much time decoding and encoding. I think there's a lot of different use cases for it. We were obviously sort of just using a sports use case that we had as a piece of this, but we've been modeling this with, at the moment, with a couple of broadcasters who want to use it on their 24/7 live feeds to do information for the models that may help with ad insertion or may help with other pieces of the programming. We had talked about closed captioning. This helps well with automating some of the closed captioning work and keeping the feed in, keeping the captions in better sync with the content that's actually going on. So there's a variety of places that it'll get used. It's very early. This is an unreleased product today. Switch is going to actually come out. They've productized it as calling it just the AI router. And it'll be in preview at NAB in a month. And they'll be launching it at IBC in September. And I think that's the key takeaways is I think it's time to revisit what mezzanines we're using. We've all gotten pretty used to using JPEG XS in particular. I know I had. But there are other things out there, and I think that it will change the way we want to think about deploying for certain productions. And it's worth, if you're unfamiliar with Switch.io, it's worth checking out their network services. It's super efficient and useful, and I think it's a ridiculous price. I looked at the costing of it, and it was like it added 4 cents an hour to the production costs for the work that we were doing. So it's pretty low cost at the end of the day to be able to pull true multicast into the cloud. Doesn't do PTP on AWS, I'm afraid, because of the way the network is designed, but it does do PTP on Azure and OCI. And that's it. I'd love to, I'm sure there's questions.
Question. Okay, let's start with the front row.
Yo. You mentioned 11 Labs as like one of the integration models. Yeah. Like, what do you see as the biggest barrier to any third-party model, like adopting this paradigm for ingestion and egress of their information?
Yeah, I mean, we didn't actually have to do anything for the models at the end of the day. So I am actually working with a couple models to get them to be able to ingest VC6 natively. In a couple of scenarios where we didn't have time to do that, then we were able to, at the point that we were multicasting out, we could flip it back into something that it understood. But we were doing whatever the cut down piece was. You unfortunately inject latency into it at that point, which is the thing we were trying to avoid. And we did see that it was, at times, it was still in the millisecond range, but there becomes a point where like you just don't want to slow down any of the traffic and you don't want anything to fall behind. So I suspect there will be more, whether they adopt something like VC6 natively or other codecs that have a scalable video ladder in it and regions of interest. I'm sure others are on the horizon that are being worked on. And so I suspect that they will also become part of what a model can take in because it just benefits them at the end of the day.
Thank you.
Sure.
Okay. Unless I really misunderstand what you're saying, I think I have to speak up in defense of the JPEG 2000 family of codecs.
Sure.
Uh,
They're wonderful.
so like, and in particular, the HTJ2K codec,
Yeah.
we have like a ton of experience with it. And so first of all the JPEG 2000 codecs are multi-resolution. They're wavelet based. You can basically decide how much resolution you want. You could decode a really low res if you want to do, use it for like finding where the interesting parts of the frame are. And, I'm surprised that people like at SMPTE didn't come back and at least like the JPEG XS people would say, wait a minute, you can do this. And like, I know, okay, let me tell you, since I have the most intimate familiarity with the HTJ2K.
Sure.
You're saying like you have to decode an entire frame. This is not true. We can decode like, I think the minimum I've ever tried is 11 lines, and I know that we, in our proxy workflow, it's 44 video lines, end-to-end latency, encode, decode. So that's nowhere near a frame, okay?
Correct.
So, and we can make proxies out of it, full res, all of that. And this is all running on CPU. We don't use GPUs.
Even in the CPU version of VC6, so the comparison that we ran here was GPU based on the left, on the right is GPU, on the left it was a mix. But we did do comparisons of JPEG 2K against VC6. We still saw a pretty dramatic decode difference.
Yeah, you have to be really careful when you say JPEG 2K, whether you're talking about the main standard or one of the ones that's designed for efficiency, like XS or HT.
Sure.
And like I say, we're totally on CPUs, and we get like, boy, I don't know, I'd say encode we can do at least 120 frames per second, and we can decode like way more. And so this is the other thing, like region of interest is like when the decodes are so cheap, it kind of almost doesn't matter because you can you can decode a close size and then crop it, and you're dealing with a codec that doesn't have IP licensing things, which you're going to have people are going to have a real problem with VC6 with this. So anyway, I guess my takeaway is if broadcasters are going to switch to another codec, they should probably do something that doesn't have like a whole lot of IP stuff on it. And I speak of this as a former MPEG person, so like I know about all of this stuff. And if it was me, I would be using something like HTJ2K because I think it will work really well in this application. But that's just me.
I love a differing of opinions. I will tell you, in everything that we tested with the J2K, and I don't have it written in front of me, I think this was NV JPEG that was being used for that. We did see a difference in it, and even just coming from a codec world, and I'll just tell you, we always had issues with JPEG 2K decode times for the workflows that we had. I understand that there's always going to be someone who's like, that doesn't have to be that way, but in operations and broadcast, it often was, and that's why XS was used quite a bit more, but there's still a lot of people that prefer ProRes as well, which is a proprietary codec. So I think I'll agree to disagree, but I agree also that there's a wealth of different flavors of JPEG that you can go use, and not everybody wants to, even if it's open source or even if there's no licensing attached to it, they don't necessarily want to go with it because of either a licensing issue on their side or some other legal issue that may come into play for how they use their codecs.
On the topic of codecs and encoders, I was curious, for this project, how are you sourcing your VC6 encoder? Are you writing it in-house or licensing something?
So this one was just part of an FFmpeg build that they have that's already available. But there are other encoders that are currently in the midst of adding it as well. But this was just FFmpeg.
Thank you.
So you had mentioned that you're using AI to zero in on specific players to reduce the amount of actual video frames you have to encode,
Yep.
right? Can you go back to that slide? I think you had
Sure.
a performance slide for that.
Was it, you mean this one, the video that was
Yeah,
playing?
I think it was this one, yeah.
Yeah.
So you were talking about how we can use this for like live ad insertion, right? So let's say that maybe like a player or something had a specifically good play, and maybe they were featured in an ad and they want to run that ad in the next ad break or something or whatever, right? So part of this, my main question comes down to when you're looking at sporting events, one of the biggest things people are into these days are like low latency when it comes to sporting events. So did you see any significant issues running these things through basically AI with your latency, in respect to latency, around how long you were able to actually transmit the feedback to your ad providers and the such, right? Because my primary concern with this kind of technology is that you're going to be doing this kind of AI post-processing on the feed, and it's going to add latency to the stream overall, right?
Yeah. So because keep in mind that all of that signal routing that you're seeing is really a multicast. So all the yellow, which is very hard to see, unfortunately, under this lighting, is multicast feeds that are sending the source signal, and then the red and blue legs are the data that the AI model is feeding back to the central switching point to help make decisions. So like in that top model, it's basically identifying players, giving us coordinates for everybody, so that we can identify them, and then the next model is getting facial recognition and other pieces of it. But all of that's happening effectively, I mean, as close to real time as possible, given that we're multicasting the feeds. Yes, there is time for the model to do its work, but the model is efficient with what it's getting, because other than actually the first one wasn't even getting the highest resolution. We started with a higher resolution, but we ended up at the 540p.
Okay.
For what it was getting, because it didn't need to identify faces. It just needed to be able to identify players
right.
and numbers.
That makes sense.
We wanted the shirt number.
Thank you.
All right, any other questions for Andy? All right, right on here on the side.
So, has there been any, what about NPUs, effectively?
In views?
NPUs.
What about them?
I guess, so it's an partially AI assisted model for a codec. So has there been any handing off of render time to NPUs?
Got it. No, for the purpose of this, we weren't. I mean, we were doing this in partnership with NVIDIA as well, so we had access to all of the GPUs that we wanted to run for it. But as I mentioned, we're in the midst of playing around with other models now, where we can run a VC6 encode off of a flight pack, which is why we want some ARM processing capabilities. So there's a number of other encode and decode capabilities that I think Vnova is looking to add to it over the next year. For now, they've got the CPU and GPU pieces.
So distribute over time based on hardware availability.
Yeah.
Yeah.
And customer demand.
Yeah.
All right, any other questions? Thank you so much, Andy. Let's put our hands
Thank
together
you.
for Tandy.